Hello, welcome back. This is Calculus by Dr. Oz. Today we're going through an exercise where we're going to find indefinite integrals by using trig substitutions. But the problem here is that the trig substitution is not provided to you. Is it x equals a sine theta, or a tan theta, or a secant theta? So we don't know exactly which one. We know, in fact, which type of substitution is the most applicable to the given integral. So this is going to be classified as, if you have the sum of the squares, then you must have tan type trig substitution. If you have the difference of the squares, you have either sine or secant, depending on the position of the constants and the variables. So I don't want to give you the details right now, because you're going to see all of them in the videos. I will have one video for each. So let's get started. All right, let's start with part A. Let's look what we have here. So we have the radical. 25 x squared plus 4, which is definitely 5x quantity squared plus 2 squared. So it's the sum of the squares, and there's a specific trig substitution for this purpose. Okay, and in fact it's u equals a tan theta. Okay, so we have to determine exactly what that is. So let's see, we have a to be equal to 2, and I'm going to use 5x. So I'm going to use 5x equals 2 tan theta. And let me just tell you why. Because I want to have a perfect square inside the square root so that I can get rid of the square root. So since a here is 2, so the coefficient of tan should be 2, but also I want to get rid of 5x in some sense that when I take the square of that, that should be like 4 tan squared, same as like the coefficient is like same as this one. Okay, so let me just write it down. Maybe you will see that time better. So this in turn to be like 4 tan squared, right? 4 tan squared theta plus 4. When you pull out 4, this is tan squared plus 1. And we're using the Pythagorean identity that this is equal to 4 secant squared theta. Because 1 plus tan squared is secant squared. Here we go. I have my 2 secant theta. I have no square roots anymore. Okay? So this is sort of like the rationale of applying the trig substitution. Okay? So a, the constant squared, just goes up here. But also the stuff that you call 2 tangent theta should be 5x here so that you get to the perfect square. Okay? So once we have the substitution, we should also look at the differential of that. Okay, so for that reason, I'm going to erase this all the way. I'm going to write just 2 secant theta here, since we had this calculation already. Okay, so 5 dx is the derivative of 2 tan. So 2 secant squared theta d theta. Okay, so in other words, 1 dx is going to be 2/5 of secant squared theta d theta. Okay, so let's just put a border here, and then let's try to rewrite this integral here. Okay, so the radical term is going to be 2 secant theta. The bottom is, let's see, here x is 2 over 5 tan theta, right? So I'm going to have 2 over 5 tan theta raised to the power of 4. Okay. And dx is here, out of here, dx is 2/5 secant squared theta d theta, right? So I'm going to go ahead and then copy that down here. 2 over 5 secant squared theta d theta. Okay. Let's simplify this expression a little bit. So the bottom is 2 to the 4th 5 to the 4th tan to the 4th. So let me just write that explicitly. And then you have another 2 to the 2/5 and secant squared theta, theta d theta. Okay? All right, this 2 is going to cancel this 4, and I have 3 left here, right? And this 5 is going to cancel. I'm just canceling 1, 2, 5 from this essentially, okay? 1, 2/5, I mean. All right. And then I can flip that over. So 5 cubed over 2 cubed. This I still have 2 times here, right? Times 2. Secant cubed theta divided by tan to the 4th theta d theta. Okay. So let me just also continue this border right here. Okay. So this in turn becomes 125 divided by 4 because you have 2 cubed and at the top you have 2. That's simplified as 4. So right now what I want to do is, let's put the integral back here. Okay, what I want to do here is to use the definition of secant and tangent. Okay, secant is 1 over cosine. So 1 over cosine cubed theta, right? So 1 over cosine cubed theta. And tangent is sine over cosine. I'm going to flip that over. So it's cosine to the 4th, sine to the 4th, d theta. Okay. All right, let's see more. Let's have more cancellations here. So cosine to the 4th and cosine cubed. So that's going to cancel this 4th power, and I have only cosine theta at the top, right? I still have sine to the 4th. I still have 125 divided by 4. Let me continue this at a newer slide. Okay, so I have 125 divided by 4. Cosine over sine to the 4th. Okay, cosine over sine to the 4th, right? All right. So now I have to take care of this integral. This integral is a known integral. In fact, I can use a u substitution for that. And here is the u substitution. I'm going to call the bottom sine, just sine, not together with the power, just sine, to be u, so that du is cosine theta d theta. That's what I have at the top, right? So this cosine theta d theta is what I have at the top. So this integral becomes du over u to the 4th. In other words, u to the minus 3 du. Minus 4, I'm sorry. Minus 4, right? I can use the power rule for integration. So u to the negative 3 plus c. Let's simplify that even further. 12, okay, minus 1 over u equals sine theta. I'm going to write it as a reciprocal 1 over sine cubed, okay, plus c. All right. So let's go back to the transformation here. I have tan 5x equals 2 tan theta. I need a triangle. 5x equals 2 tan theta. Okay. In other words, tan is 5x over 2. Okay. Let me just put that triangle right here. Okay. Well, tan is opposite divided by adjacent. There we go. I have my opposite here, adjacent here. Okay. That's 5x over 2. And the hypotenuse is going to be 5x squared, quantity squared, plus 4, plus 2 squared, which is 4, right? So this should be 4 plus 25x squared. Okay? So now let's continue here. I have negative 125 divided by 12. I need sine theta, right? And that's something I have to read from the triangle. In fact, theta is right here, so I forgot to put that down. And sine is, let's see, sine is 5x over 4 plus 25x squared in radical sine, right? Radical of that. So 1 over, I'll use another color here. So 1 over 5x divided by 4 plus 25x squared radical quantity cubed plus c. Okay? And you can simplify this further. You can simplify this further as, let me just put the c here. Okay? You can simplify this further, minus, let's see, we can flip the bottom over with the cube, minus 125, 4 plus 25x squared to the power of 3 halves, okay? Okay? That is also coming along with 12. 5x cubed, and that is 125x cubed plus c. Okay? And as you see that, I can cancel out, let's see, 125's here. Okay? So let's cancel out 125. And you have minus of minus 4 plus 25x squared to the power of 3 halves divided by 12 plus 12x cubed plus c as the final result of the integral in part A. Okay. I think that covers everything that we had for part A. And for part B, please move on to the next video. All right, thanks for watching. Bye.